Alright, you guys, if you guys could please turn to the first page in your notes. This unit is basically gonna review the most important things that you're gonna need to know to start learning calculus. So a lot of the stuff is gonna be stuff you've learned last year, some of the things you've learned the year before. It should be mostly review. However, there will be a few new things here and there. I'm not sure why that just popped up. Alright, so first thing, increments. If a particle moves from the point x1, y1 to the point x2, y2, the increments in its coordinates are delta x equals x2 minus x1 and delta y equals y2 minus y1. This delta also can be read as change in x or change in y. So for example, if these were my x1, y1, x2, y2, this distance here would be my delta x. Okay? And this distance here, whoops, would be my delta y. Okay? Let's do an example. Go back to blue. Okay, find the coordinate increments from 4, negative 3 to 2, 5. And then find the coordinate increments from 5, 6 to 5, 1. Okay, so delta x, I think that's a different shade of blue. There we go. Delta x, basically just take the x's and subtract them. So I've got 2 minus 4 equals negative 2. Delta y, we got 5 minus negative 3. Minus negative becomes a positive. This is going to be 8. Okay? Alright, so that's the first part. The second one, delta x equals 5 minus 5, which gives me 0. 6 minus 1 is delta y. That gives you 5. Okay? Alright, go ahead and pause the video here and try this one. Alright, these are the answers you guys should have gotten. Alright? Hopefully you guys found this pretty easy. The delta x and the delta y are also commonly called the rise and the run. Those are terms you guys should be familiar with. Another term you guys should be familiar with is slope. Here's the definition. Let P1, x1, y1, and P2, x2, y2 be points on a non-vertical line L. The slope of L is m, rise over run, delta y over delta x. So the increments of y over the increments of x. Okay? So, for example, what are the vertical and horizontal lines through this point? Alright, now, hopefully you guys remember that vertical lines, if you were to draw this, that's not so straight, better. The point 2, 3 is going to be right here. A vertical line is going to go through this point, x equals 2. Okay, remember vertical lines only have an x in them. The horizontal line, same idea, except with the y. So you're going to have y equals 3. Alright, pause the video here and try this one. Alright, these are the answers you guys should have gotten. Okay, point slope form. The equation y equals m times x minus x1 plus y1 is the point slope equation of the line through the point x1, y1 with slope m. Some of you guys may be more familiar with this equation looking like this. I'm just going to write it off to the side. This is pretty much the same equation, just with the y1 subtracted over here. Either way, it's fine. I'm going to use this version of the equation for this example. Write the point-slope equation for the line through this point with this slope. Basically, we're just going to plug it in. So I've got y equals m times x minus x1 plus y1. Here's my x1, y1, and here's my m. Just plug it in. Y equals m times x minus x1 plus y1. Done. Alright, go ahead and pause the video. You guys try this one. Alright, this is the equation, oops, in point-slope form, but I can see how you would want to simplify it. If you gave me this, I'd probably accept it, but this is technically in point-slope form. Alright, the equation you guys are more familiar with is slope-intercept form. This is your y equals mx plus b equation. So the equation y equals mx plus b is the slope-intercept equation of the line with slope m and y-intercept b. So important to note here, this is your slope, this is your y-intercept. Okay, so for example, write the slope-intercept equation for the line through these 2 points. Okay, first thing we have to do, we have to find the slope. Slope is delta y over delta x. So I've got 4 minus negative 1 over 3 minus negative 2. These become positive. So I've got 5 over 5, which gives me 1. There's my m. Okay, we can use the slope with either of the 2 given points in the point-slope equation. Let's use this one. So I've got y equals, y equals mx plus b. Negative 1 equals 1 times negative 2 plus b. Negative 1 equals negative 2 plus b. If I subtract negative 2 to the other side, I'm sorry, add negative 2 to the other side, I've got, here, I'll put that there. Those cancel out. So I've got b equals 1. So here's my m, here's my b. Y equals mx plus b. You would have gotten the same result if you had plugged in the other point. Alright, go ahead and try this one. This is kind of a trick question. Write the slope-intercept equation for the line with slope m and y-intercept b. That's the answer. Voila. Alright, general linear equation. Alright, general linear equation. The equation ax plus by equals c, a and b can't both be 0, is the general linear equation in x and y. This is the form you generally see problems in when you first get them, and then you have to do various things to convert it into either slope-intercept form or into something else to do whatever the problem asks you to do. So for example, find the slope and the y-intercept of this line, then graph the line. The easiest way to do this is to just put it in slope-intercept form. So what I'm going to do, I'm going to subtract 8x from both sides. I'm going to leave the negative 8x out in front. If you want, you could have 20 minus 8x and then switch it. I just kind of skipped that step. Then I'm going to divide. Make sure you divide both terms by the 5. Whoops. So now I have y equals negative 8 over 5x plus 20 over 5. 20 over 5 is 4. So now hopefully you guys can see this is your slope and this is your y-intercept. So m is negative 8 over 5, b is 4. Okay. Alright, go ahead and pause it here. Oh, I'm sorry. Gotta do one more thing. Graphing. When you're graphing from slope-intercept form, you're going to start with your b. which in this case is 4. Our slope is negative, so I'm going to go down. I'm going to go down 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to draw these little dashes. And then over 5. 1, 2, 3, 4, 5. And there, whoo dear. Close enough. There is the equation, or the graph of my equation. Alright, go ahead and pause it here. Try this one. Alright, seeing as this problem is a little bit different than the last one, I'm going to actually do this one out for you guys. It's better to graph this one first, just because you're given 2 points right at the get-go. So here's 0, 0. Here's 2, 3. So, there's our line. Now we just need to find the equation. The slope, as you can see, is 3 over 2. Okay? And you can see that your y-intercept is 0. So the slope-intercept form of this equation would be y equals mx plus b, y equals 3 over 2x plus b, which is 0. Okay? But this is not the general linear equation. Oop. We need to make it look like this. Okay, so what I'm going to do here, I'm going to subtract 3 over 2x from both sides. Actually, let me rewrite this over here. So I've got y equals 3 over 2x. I'm going to subtract 3 over 2x from both sides. So this goes away, and when there's nothing over here, we're just left with a 0 on this side. Now I'm going to do the same thing I did over here. I'm going to switch. I'm not going to write y minus 3 over 2x. Instead, I'm going to write the x out in front. You could write y minus 3 over 2x first and then switch them. That's fine too. Now, it is in the correct form. 3 over 2x plus y equals 0. The x's line up, the y's line up, the numbers line up. That's the answer. This would be almost correct. You would get partial credit if you gave this answer, but you would not get full credit because you did not put it in the form that it asked for. Alright, example 6. Write an equation for the line through the point negative 1, 2 that is parallel and perpendicular to this this line here. Okay, now a couple things you need to remember. Parallel lines have the same slope. So if I'm looking for a line that is parallel to this line, and the slope of this line is 3, the slope of my parallel line is also going to be 3. So if I'm looking for the parallel line, my slope is 3. Okay? That is not going to be true for the y-intercept. Just because the lines are parallel does not mean they have the same y-intercept. They only have the same slope. The y-intercepts are actually going to be different. They're always going to be different. Okay? So make sure you write down that the slope is the same. Your m is the same, not your b. Now, a perpendicular line, if you guys remember, has opposite reciprocal slopes. Opposite reciprocal means you take this, you flip it upside down, and you change the sign. So the parallel line is going to have a slope of 3, the same slope. A perpendicular line is going to have a slope of negative 1/3, the opposite reciprocal. Okay? Now, I'm going to do the same thing with each of these slopes. And I'll use different colors. Let's see, I'll use green first. So I've got y equals mx plus b. Here's my x, here's my y, here's my m. I'm just going to plug it all in. So I've got 2 equals 3 times negative 1 plus b. 2 equals negative 3 plus b. I'm going to add 3 to both sides. 5 equals b. So this equation, or this, the parallel line is going to be y equals mx plus